So hello everyone. So I hope you're doing well. And in this video, we are going to talk about our last quarter, our fourth quarter. And I am pretty sure that you already answered your module. Some of the in the summative test, some of them are already answered. But this video will help you more understand about our topic from page 1 to page 5. So we have two main topics here. We have parametric statistical inference estimation, and the other one is the hypothesis testing. So in this video again, we're going to talk about page 1 and 5. And be sure to have your module beside you so that it is easier for you to catch up. So we are going to focus on page number 2 and 3, estimating population mean. If you have more questions about page 1, you can just PM me. And we have here this one, the z values can be seen also in your z table. I know you already know what is the z table. So we have here, take note of before we proceed to the main topic. Let's have first these what's this key points. So we have level of significance, confidence coefficient. So we have here, this is mostly used 90%, 95%, 99%. So this is the alpha. This is z sub a. So z sub the alpha. That's it. Okay. So we are going to have this one. Later on, you will more videos to come. You will have this one-tailed. You will know this one-tailed and also the two-tailed. Alright, so we are not going to focus this first because we're going to explain this further in the next video. Okay, so let's have this estimating the population mean, page 3. So computes the confidence interval estimate. This is our code. And then key concept. So the point estimator of the mean is mean. So remember, this one is the mean for the population, and this one is the mean for the sample. The interval estimator of the mean of the population is the 1 minus alpha multiplied to 100% confidence interval given by, these are the formulas. Okay, so mean of the sample minus z sub alpha over 2, or what we call two-tailed, multiplied to standard deviation over square root of n. So as you can see, it is a comma because it is in interval. So in between that specific number to that specific number, so that is in between. So say for example, when we say in between or coordinates, the same thing as that. So when standard deviation, when the variance is known, this is the variance, or n is greater than 30, then you're going to use this one, this formula A, or formula this one, formula A. And if it is n is less than 30, then we're going to use this formula B. So remember, we're going to use, in formula A, we're going to use z table, and for formula B, we're going to use a t table. Okay, so these tables can be seen at the last page of this learning activity sheets. So here I'm going to show it to you. Here, okay, here, it's not here. Okay, but in your module it's there. Okay, so by that, let's go back to our discussion. So again, you already familiarized with those t-table and z-table. So you already know how to use that one. So make sure that it's on your side so that it's easier for you to look for the answer. Okay, so as you can see here in our module, so we have here two formulas. The z table, the formula using the z, and using the formula using with the t table. So sige daw, try to look for the area of 1.56. 1.56. So this is the t table that I was mentioning. See that, try to look for 1.56 of the z table. 1.56, so that is the z table. So 1.56, what could be the area? So that is negative. So 1 here. So 1, let's have a review lang niya. 1.5 and then 6, this one. Okay, so in line here, where's the intersection? There you go. So do we have the same answer? It's 0.9406. Do we have the same answer? Okay, that's good. Okay, let's continue. So this is also our t table. This is used if your n, the value of n is less than 30. Okay, so as you can see here, this df here on the side, this df on the side here is what you call the degrees of freedom. Okay, so this thing here is just the same with your z table. Yes, the same with your z table. Later on, I'm going to have example for this. Okay, let's proceed. So remember that when you are using a t table, you are going to look for the v, which is n minus 1. So you need to subtract 1 from your sample size, from your n, so that you will use this one in the t table, this one. So df is equals to n minus 1. So degrees of freedom is equals to n minus 1. Do not forget that one. Okay, let's have an example. The laboratory department of a certain hospital collects data on leukemia patients, of which one of these is that the patients of hematocrit. Accordingly, it is assumed that the patients' hematocrit are approximately normally distributed with a standard deviation of 11.07. If a random sample of 50 patients have an average hematocrit of 36.38, construct a 90% confidence interval of the mean hematocrit, where the mean of the population of all leukemia patients at that hospital. Okay, again, so this is an example you already given, but if you are really a hard time on understanding the problem, then you can just read it again. So again, so we're just going to continue. First, we're going to look for the given. Okay, so we have here the standard deviation, automatic standard deviation. There you go. It is known, and of course, it is very important for you to know the number of samples. So it is greater than 30. Thus, we're going to make use of here. That's why we are making use of the z, or the formula A. So n is equals to 50. So next is we have another clue here, the average or the mean. The mean is 36.38. Okay, then construct a 90% confidence interval. So we have here 1 minus alpha times 100%, that is equals to, remember that 90% is just equals to 0.9. So 1 minus 0.9 is 0.9. Are you familiar with this one? Go back to the first page, 0.10. So that is your alpha, 0.10. So that is 1.28. I'm going to correct this one, that is 1.28. Anyway, it's okay if you're using it with 2, that's okay. So that's it. So no, wait. No. Let's go back. It's not 1.28 because it's not yet a formula. So since the standard deviation is known, then we use this one. Okay, the standard deviation is known. So again, go back to the formula. I'm going to delete it first. Again, it's not 1.28. So the mean of the sample minus z sub alpha over 2, or the two-tailed, multiplied to the standard deviation over square root of n. And as you can see here, the difference between the two is this is subtraction and this is addition, since it is an interval. Okay, so To substitute this formula, so your mean is 36.8, 36.38 minus the, why did we use 1.645? Because as you can see here, your alpha, okay, your alpha is 0.10. So your alpha is 0.10. Of course, you look for this one. Alpha, z sub alpha. Wait. Oh, erase. Okay, so it is alpha 0.10. You do this one, and then remember that the formula is z sub alpha over 2, so that's why we are using this one. We are not using 1.28 because it is not two-tailed. We are using two-tailed, so that's why it is 1.65. Okay, go back to the, that's why we have here, we just substitute here 1.645, the same thing as here on the addition side. So standard deviation, we have 11.07 over the n square root of 50. Okay, just substitute the formula and then simplify. So we have the interval 33.80 to 38.95. This makes the confidence, this makes the interval, this interval will make the confidence interval into 90%. So in between of this interval, you will have a 90% confidence that your study is correct. Okay, so that is how you do it when you have greater than 30. What if you have less than 30? So we have the second experiment, or second example. The experiment scores of 7 chemistry students are 9.8, 10.2, 10.4, 9.8, 10, 10.2, and 9.6. So find the 95% confidence interval for the mean score of all chemistry students, assuming an approximate normal distribution for student scores. So solution, we have 2 steps before we can get the final solution. So we have first, you're going to get first the mean, because the mean is not yet given, so that's why you will get first the mean. So just add all the given. We have 9.8 and then divided by the number of sites. So we have 7. So 1, 2, 3, 4, 5, 6, 7. That's why we divided by 7, and then your sample mean, or the mean of the sample, is 10. The mean of the sample is 10. So where you already have now the mean. Next is solve for the sample standard deviation. We have this formula. So you get to list all the x's. We have here the table. You are familiar with this because you already did one in your lesson 3. Yes, the mean. Okay, so x, then you subtract by your mean, which is 10. That's why we have, where did we get this negative 0.2? That is 9.8 minus the mean, which is 10. That's why we have negative 0.2. 10.2 minus 10. That's why we have 0.2. Okay, and so on and so forth. And then after this one, since you have negative 0.02, no, it's not 0.02. You multiplied it 2 times. Not 2 times. 2 times itself. So negative 0.2 times negative 0.2. Negative times negative is positive, so we have 0.04. Okay? This one, 0.4 times 0.4, so that's why 0.16. Okay, that is how you're going to get it. Then you get the summation, the total of this one, the total of x minus the sample mean, so you have 0.48, and then you can now solve the sample standard deviation by substituting this formula. So the summation of x minus the x, the mean squared, is 0.48, so that's why we have here 0.48. Then the n, remember your n is equals to the number of data, so we have 7, so 7 minus 1 we have, okay, so we have 6, so 0.48 divided by 6, we have 0.08. Remember that is still the sample variance. We need to get the standard deviation. That's why we do the square root. square root of the sample variance, which is square root of 0.08. So we have a 0.2828, or approximately 0.283. Okay, so I hope it's clear to you how to get the standard deviation. So that is 0.283. Next, so we can now have the given. We have now the n. Remember the alpha, you are given a point at a confidence interval. The confidence coefficient, we have 95. So in getting that alpha, you just subtract it to 1. So 1 minus 0.95, so 0.05. That is your alpha. Again, do not be confused of 95%. That is what you call the confidence coefficient. And then if we are going to get the alpha, just subtract it to 1. So 1, translate that 1 into decimal point. So you have 0.95. Then you have now your alpha, which is 0.05. Okay, so is 0.05. So now it's, remember, the formula A and formula B are not the same. So that's why you need to be careful, because we are now using t. Why we are using t? Because the number of your n is less than 30. Okay, though your standard deviation is now known, but still your n is less than 30. That's why we are using t table. So again, so where t is 2 tails, so t sub alpha over 2. Okay, so remember the degrees of freedom, n minus 1. So where did we get this 2.447? So since our alpha is 0.05, we divide it by 2. So we have now 0.025. So go to your t table at the back. So look for 0.025. So as you can see here, this is this is the 0.025. Okay, now what is your degrees of freedom? Since your degrees of freedom is v is equals to n minus 1, so degrees of freedom is equals to, what is your n? Diba 7? So 7 minus 1, that is equals to 6. So get the intersection of this one. Okay, get the intersection. So again, 0.025, and then the degrees of freedom is 6. So get the intersection. That's why we have 2.447. Actually, this is just the same to the z table, but the difference between them is the z table do not have a degrees of freedom. Okay, so that's their difference. You need to be careful with your degrees of freedom. Do not forget that the n minus 1, that is your degrees of freedom, not the n. Okay, so that's how to get your degrees of freedom, or the value of your t sub alpha over 2. Why did we divide it by 2? Because of this formula. Again, that is two-tailed. Alright, that is two-tailed. Okay, that is two-tailed. Next, so after that, we can now substitute. Again, the only difference is the subtraction and the addition. So you can just simply substitute all these letters here, because you already have the value here. Okay, you already completed the given. So your mean of the sample is 10. That's why we have 10 here. Then this minus t sub alpha over 2 is 2.447. Then your s, or the standard deviation, is 0.283. And then over square root of 7, because it is n. That's why we are using 7. It's not 6, because 6 is the degrees of freedom. Okay, it should be 7 because that is 9. Okay, the same thing as here. Then comma, then 10 plus 2.447 multiplied to 0.9 square root of 7. Then simplify. Then you have 9.73 to 10.46. This interval will make the if your answer is in this between this interval, then your research is in 95% confidence coefficient. So meaning there are only small error if you are not into this interval. Okay, so that's how you get the estimation of the population mean. Let's have the estimating the population proportion. So estimating population proportion, what's the difference between the population mean and population proportion? So it's easier to see when you just read the question. So there's an experiment, of course, the population, where X represents the number of successes in N trials. So there is a ratio, there is a fraction, not the same thing in the population mean. The clue there is you have the mean, you have the standard deviation, like that. But in the population proportion, you have successes. Say for example here in a binomial experiment, we already discussed it in lesson 4. X represents the number of successes in N trials. On the other hand, remember the confidence interval of population P is given by, so this is the formula of the confidence interval, P hat minus, again, Z alpha sub alpha over 2 multiplied to P hat times Q hat over N. Okay? So the same thing as on the other side. So our P hat, how to get the P hat, that it's X over N, that is the proportion, and Q hat, that is equals to 1 minus P hat. Okay? So example, in a random sample of 200 COVID patients, 138 were found to be negative. So the other are positive. Okay? So again, successes. So fail or success. So again, we have here the numbers. So how many samples do we have? 200. And then how many were negative in COVID? We have 138. What is our confidence? Coefficient? 95%. So we need to find the confidence interval within this our confidence coefficient who are negative. Okay, specifically the negative. So we are given X is equals to 138. So why 138? Because we are asked to find the negative of COVID. And then remember that N is equals to 200. So that's why we are using Z, because that is larger number. Okay? So hence, how to get the P hat? We have X over N. So we have the proportion 138 over 200. That is equals to 0.69. And the Q hat, so since our P hat is 0.69, so 1 minus P hat, so we have 1 minus 0.69, which is 0.31. And then after that, we can just simply simplify this one. Remember, 0.95. So convert it to decimal, so 1 minus 0.95, that is 0.05. Again, go back to the first page. We are not using 0.05 because look for this one. Is this one? Is this A or B? In the formula, we are going to use B. So 0.05, that's why we are using 1.960. Alright, so we have here 1.96 is just equals to 1.960. Okay, do not be confused. 0 at the last part do not have a value. Same as 0.0550 is just equals to 0.05. Are we clear? 0.50 is just equals to 0.5. 0.250 is just equals to 0.25. I hope it's clear. Please do not be confused of those numbers. Okay? But when you have 0.025 is not equivalent to 0.25. Please be careful because the 0 is before 25. So it's just the same value if those 0 is at the last part. Okay, they have the same value. So if 0 is on the before the digit used, it has a value. But if it is after or the last part of the number, in decimal point, there is no value. But if, do not be confused, it is in 1000, this is the last part, there is a value, okay? Before the decimal point, okay? And the last part, it is taking consider nga decimal form. We are talking about here with decimal, ha? Okay, so in decimal, we are talking about in decimal, if the last digit is 0, then it is just they don't have the value. Okay, so that's it. All right, let's go back to our solution. So by this we have now completed. So by this we can now simplify or substitute the p hat, which is 0.69 minus, what's this? The z sub alpha over 2, which is 1.96 or 960, multiplied to p hat times q hat, so 0.69 and 0.31. Okay, then over n, which is 200, and the same thing as that. So then you simplify, please. That's why I'm not do not round yet if it is not yet the final answer. Okay, do not round yet if it is not yet the final answer. The same thing as this one. Oh, okay, do not round yet the answer if it's not yet the final answer. So we have now the final answer, 0.63 to 0.7. This means that we are 95% confident that the proportion of patients who are negative of COVID lies between 63% to 75%. Okay? So 63. How about, guys? So try to solve. If we are looking on the construct a confidence interval, okay? No, it's not just an activity lang, so that you can practice. Construct the interval, confidence interval, a confidence interval of all COVID patients, what's next? Of all COVID patients who are, this time, since we already solved the negative, who are positive. Alright, sige daw, how to solve this one? Positive of COVID. How to solve that one? So clue, since you have the negative, which is the negative of COVID, is how many? 138. So what is the positive? Okay, just subtract 200 minus 138. So that is the value of the positive. What is 200 minus 138? Alright, that's correct. So 200 minus 138, that is 62. So therefore, the positive numbers of positive is 62. So try to solve that one. You are using 62. Okay? So if you have more questions about this, you can just PM me. And of course, thank you for listening to this video. I hope you learned something, and I hope it's clear to you how to use the p table and z table. God bless, and thank you.